Hello students, I Sandeep Sharma welcome you in the next class of chemical kinetics. In the previous video, I have shared you how to define instantaneous rate, average rate and how to calculate instantaneous and average rate of reaction. Now today we are starting with molecularity of reaction. It is a simple terminology and defined as number of reactant particles which must collide simultaneously. Remember, this is a very important word to define molecularity of reaction. It is number of reactant particles which collide simultaneously in a reaction. For example, suppose it is an elementary reaction. I hope you remember elementary reaction means the reactions which complete in single step. So here this is example of elementary reaction where 2A plus B convert into product. Because it is elementary reaction, the reaction complete in single step. It means 2 plus 1. 3 particles are colliding simultaneously and therefore the molecularity of this reaction is 3. I repeat, in elementary reaction, it's very simple to find out molecularity of reaction. It is sum of the stoichiometric coefficient of elementary reaction, and you can say this is molecularity of reaction. But this is not definition. We have defined this earlier. It is number of particles which must collide simultaneously in the reaction. Now before we proceed further about the properties of molecularity of reaction, look at one example of complex reaction. I hope you remember complex reaction, the reactions which complete in 2 or more steps. One of the example is nitrogen dioxide react with fluorine and convert into NO2F. Now this reaction completes in 2 steps. Step 1 involve reaction between NO2 and F2 converts into NO2F plus F. In second step this F will react and convert into finally NO2F. If you closely look at this two reaction, then the first step involves 2 particles. It means 2 particles are colliding in the first step and therefore the molecularity of first step is 2. 1 plus 1 equals to 2. Similarly in the second step, once again 2 particles are colliding. So molecularity of second step is also 2. I repeat, 2 particles collide. So molecularity of first step is 2 as well as molecularity of second step is also 2. Now look at here the balance equation. It says 2 plus 1. It means 3. But 3 is not molecularity of the reaction because all 3 particles are not colliding simultaneously, and this we came to know after knowing that this is an example of complex reaction. So in complex reaction, molecularity cannot be a simple addition of stoichiometric coefficient, but it can calculate only once we know the mechanism. Here 2 molecularity of first step and 2 is the molecularity of second step. One more feature about complex reaction, if you see this two reaction, the difference of the reactant NO2, this is same. But here F2 and F, if I ask you which is more stable out of F2 and F, the answer should be F2. This is more stable. This is unstable and therefore this F should be more reactive. So out of this two step, the second step should be a fast step. The reason is F is unstable, it will be more reactive. The second one is fast step. Comparatively, the first is slow step. Now the slowest step of a complex reaction decide the rate of reaction, in fact determine the rate of reaction, control the rate of reaction, and therefore the step is also known as rate controlling step, or it is known as rate determination step. I repeat, in the complex reaction, the slowest step of the reaction is known as rate determination or rate controlling step because the same step determine or decide or control the rate of reaction. Now in most of the questions you will be given which is the slowest step, so no need to predict the slower step in the question. It will be given in the question, but for few reactions which are given in our syllabus again and again, like this reaction, you have to remember its mechanism, as well as you have to remember that first step is the slow step as well as rate controlling step. So once again look at here, molecularity of first step is 2 because two particles collide. Molecularity of second step is also 2. What is overall molecularity of this reaction? So overall molecularity is always given on the basis of slower step or slowest step of the reaction, and therefore here overall molecularity is also 2. Come back to the previous slide. Now some more features about molecularity of reaction. Molecularity of reaction cannot be 0 because if there is no particle, that then reaction is not possible. Molecularity of reaction cannot be a fractional number. It cannot be 1.5 or 0.5 or 0.7 because it is not possible that a fraction of particles, half particle or 3/4 particle collide. So particles always collide in whole number, and therefore the molecularity of reaction cannot be a fractional number. Generally the molecularity of reaction is 1, 2 or 3. It is generally not more than 3 because once again it's very difficult to collide 4 or more particles simultaneously. It is given on the basis of balance equation, hence not gives any idea about mechanism of reaction. On the basis of molecularity, you cannot determine, you cannot give any idea about mechanism of this reaction. So you will have a good theoretical question based on this, all these properties, that what are the differences between molecularity of reaction and order of reaction. So we have discussed all about molecularity of reaction.